Hello everyone, my name is Wang Tianchen, and the advisor is Professor Liu and Professor Cai. The topic I'm going to share with you today is the analysis of vegetation indices to determine nitrogen application and yield prediction in maize from the standard UAV service. So, for a short introduction, there was the unmanned aerial vehicles carrying a special camera called multispectral cameras that can record the reflectance of different wavebands images individually. That is red, green, and infrared. And after some simple algebraic calculation, we can get the vegetation indices and the height of the maize at the V12 stage. The author want to use this information to first determine the most optimal nitrogen application and yield prediction. First, I want to show you some brief review of vegetation index and optical nitrogen application rates. Before talking about the vegetation index, it's important to talk the idea of spectral signature. Just like the signature of each person, the behavior of reflectance among different wavebands of each object is different. So it can be discriminate one object from the other, just like plant and soil has a different behavior of reflectance among this visible and invisible light range. And vegetative indices is originally used in the remote sensing field to discriminate the plant from the environment. And further, from the previous studies, they find that by choosing the specific waveband range, it can tell the health status of the plant. So you can discriminate a healthy plant from the stressed plant. And so many vegetative indices is derived from then on. The physiological view of this data, it shows that since the red and blue light is used in the photosynthesis, so the reflectance of these two lights should be low. And the green and near infrared are not used by the plant, so the reflectance of these two lights should be high. By the combination of these different wavebands, we can get different vegetative indices, like the green-based vegetative index and the red-based vegetative index. And about the most optical economical nitrogen rate, the idea is if we get the curve of the yield return over the different nitrogen application in the field, and also the cost of the fertilizer by subtracting the cost from the yield, we can get a new curve of the net return in the field. And it's very obvious that there existing a point called we can get the maximum return. And the nitrogen used at this point is called the economic nitrogen rate. And after that, the net return is decreasing. By reversing this relation, we can estimate the yield from the nitrogen application in the field. The field location of this experiment is located at the northeast part of the Spain, called Catalonia. And in the field, they grouped the different nitrogen fertilizer into three groups. One is completely inorganic nitrogen fertilizer from 0 to 400 kilogram per hectare. And the other is the organic pig slurry. And the rest is the mix of two. Totally, they contain 12 nitrogen application. After the drone flight by the field, they can get the different vegetative indices as mentioned before, and also the crop height from photo. Combining with the in-field collection data of SPED, the chlorophyll content, and also the yield for different nitrogen treatment, the author can now ready to do the analysis. This is the graphical display of the vegetation index of different index. And from the first glance, you can see that the left part is more bluer than the right part. And the color of the graph means the range of the value. If the value is higher, it's more close to the blue, and vice versa for the red. And you can find that NDVI and WRDVI are more closer to the upper limits. It means that it's somewhat closer to the saturation of this signal. And this is not the case for the GRVI, which can tell very detailed information in the green range. And just by looking at this picture, we cannot get enough information to make a judge that whether this indices is useful in determining the most nitrogen rate. So they use the linear plateau model to find that the economic rate for nitrogen application in the field is around 240 kilograms per hectare, which has a yield of around 16.2 tons per hectare. And they also find that there are two indices, WDRVI, the wide dynamic range vegetative index, and also the normalized difference vegetative index, has a similar threshold value around 240 kilograms per hectare. So it might be useful and potential to be the predictor for yield because they share the similar pattern for the response over the nitrogen rate. And they find that there are two different patterns. The GRVI's pattern is different from the yield. It has a threshold value around 362 kilograms nitrogen per hectare. It means that it will respond to the nitrogen application over the economic nitrogen rate. So if you use this index, it might be overestimate the yield because the keep responding at this region. And for the SPAD value, it's the contrast condition. It saturates around 200 kilogram nitrogen per hectare. So if using the SPAD for yield predicting, you might underestimate the yield. And the previous discussion is just about the pattern, which pattern is similar to the yield, and it might be useful, but it's not scientific data. So they conduct a linear regression analysis, also the quadratic regression analysis, and they find that the wide dynamic range vegetative indices perform the highest correlation with the yield. So they think that WDRVI is the best index for yield predicting. So the summary, they find that the economic nitrogen rate for yield is around 240, and WDRVI and NDVI are the potential index as yield predictor from the V12 stage. And among them, they find that WDRVI has the highest correlation with yield. And that's for all. Thank you.